Hi, it's time for another math easy solution. Here to discuss further into derivative as a function and look at example 2 of this video series. You can see the earlier videos in the video links below. Basically, this example goes like this. It states part A of it says if f of x equals x cubed minus x, find a formula for the derivative of f of x using the definition of derivative. So we're still using definition derivative. You could clearly use the derivative rules in this and get the derivative easily, but we'll just go find out how to do it using definition derivative, and then basically illustrate by comparing the graphs of f and the derivative and see how they compare basically. So let's look at example A. Part A of example 2. Okay, so basically, before I find a derivative, just recall the definition of a derivative, which just states that the f prime of x equals limit as h approaches 0 of this f of x plus h, then minus f of x, and then all divided by h right here. So all we do is plug this h in this f of x. So we just put this f of x over here in this definition of derivative, and we'll get something like f prime of x equals to limit h approaches to 0 of, now this is going to be, well, if we plug in x plus h inside this, we're going to get x plus h cubed minus x plus h, and then obviously subtracted by x cubed, x cubed minus x right here. So this is f of x, and this part right here is f of x plus h, and then all divided by h right here. So now basically we can expand this out, but before I get that out, I want to show how to expand this complex number, basically x plus h cubed. I showed my earlier video. You can see that in the video link below. Basically, I would write the top one as this one right here. So x plus h times it by x plus h times by x plus h. So this is this number right here. And then, like I showed in my earlier video, you could basically multiply this by this and this by this, and we're going to get, in this case, is going to be x cubed, so x times x times x. This is a quick way of doing it, and then plus this is going to be x times h. So you go times it by this one, then you times these two and you add them up, and you're going to get, this is going to be x squared and then h. And then same thing with this. Instead of going with this x, we multiply this by h, and then this by x or this, and add these up. So we're going to get now plus x h, and then there's another x, so x squared h, and then plus x h, and then there's another h, so h squared. And now we do the same thing but for the h. So now we're going to do the exact same thing, but now we're going to have this h times by x, and then times by these two as well. And then same thing with going over to the h, and then this. So we'll have another two pairs of stuff to add. So when we look at the h side, we go h times x, so we're going to have plus another h, actually x h, just put the h on the outside. So we're going to have right here h x, and then an x squared, and also hx, so we'll put x h, and then this is going to be now an h now. Multiply this one, and then the last pair is basically look at the h, and then x, so we'll have x h squared, and look at h, and h. That's just going to be h cubed, and this one, if you add up the like terms, is going to be equal to, well, x cubed. That's this one by itself, and now this one, there's a one of these, two of these, there's three of these actually, so it's going to be 3x squared h, and then plus there's one of these, two of these, three of these, and we're going to have 3, this is x h squared, and then plus an h cubed. Okay, so when we expand this x plus h cubed, put it over here. So just make sure you watch this part in the video link below on expanding complex numbers, and then just finally expand everything out here. Just put the negatives inside, so negative x, negative h, this is minus x cubed, then it's going to be a plus here, negative times a negative as a positive, then we're going to have, this is going to be plus x right here, and all divided by h right here. So now we just look at the like, basically cancel the like terms, etc. So this x cubed cancels with this one, so these cancel. If we look at 3x squared h, this is going to be, basically I'm just going to write down this one. This one has no other like term like it, so we can just put that down right here because you're not going to be able to cancel it. And then also this one too as well, 3x h squared. There's nothing else with an x h squared, So 3x h squared. So all we've done right now is cancel the x cubed. And then now if we look at this, this is a plus h3. Again, there's nothing else like it, so plus h3. And now what cancels here is this x and this x. So negative x plus x, that cancels. Now we're going to have a negative 1 over here, right here. I mean negative h right here. So this is the only thing left. So we get something like this, and there's an h in every term. So we could cancel out or divide it out, and we're going to get limit, as h approaches 0, and then cancel every h out. We're going to get 3x squared plus 3x h plus h squared minus 1. And now if we just plug in 0 inside these, we basically cancel these out. We're going to get 3x squared, this is plus 0 minus 1 right here. And that is our derivative. And I didn't mention why we're doing this initially, because, well, you can't just plug in 0 right here. If you plug in a 0, you're going to be dividing by a 0 which is not defined. So basically all I'm doing is rearranging so that we can cancel out the 0 and write it in a form like this right over here. So this is the derivative, and you can also see using derivative rules. If you just look at this one, it's always going to be, you put the 3 down, then minus this power on top, and then it's going to be like this one. So if you use derivative rules, you'll get that same answer. And this is it. And now if we look at part B, which is basically states compare the graphs of f and f prime, or the derivative. And if we graph this out with Google Calculator right here, we get something like this, where the blue is the f of x and the red is the derivative. And so this is the 3x squared minus 1 is the x cubed minus x. As you can see right here, the derivative it's 0 whenever there's a flat line across here. So that's exactly here where the basically there's a tangent line is 0, because remember the derivative is just the slope or the rate of change of f of x, or basically the slope of the tangent line. So basically it's 0 again here at this part right here, which it makes sense, and this is a good way to check it. And then basically derivative goes to positive whenever this is basically increasing up. And then this one here, it's negative right here. I mean, no, it's positive right here because derivative is going up, but then it becomes negative in this area from 0.5 to negative 0.5 to 0.5, basically because you're going down the whole time. So as you're going down, it's going to be negative to a maximum around here, maximum downward slope, then it goes back up. And basically that's all for part B. It's just a good way to check that you got the right answer right here. And a good way to check again is this, what are the zeros at? If it's a horizontal slope, it has to be a 0. Well, anyways, that's all for today. Remember, you can always download these notes in a Dropbox link below, and stay tuned for another Math Easy solution.